So Robin, we're at our Edge AI demo. Do you want to quickly show, or do you want to quickly explain what we want to show here?
Yeah, so here we're showing our two complementary technologies for ultra-low power Edge AI. The first one is our custom Neuton models, which are ultra-tiny, ultra-efficient Edge AI models that are designed to run on the ARM Cortex CPU of any Nordic SoC. These are generated in our Nordic Edge AI Lab with no input to our architecture or to the organization of the neural network and no optimization afterwards. The models are generated organically, neuron by neuron, to create the most efficient and smallest neural network possible, which makes them perfect for ultra-low power use cases for simple sensor data like time series sensors for example, accelerometers, temperature sensors, simple electricity parameter metering, so like voltage, current, and medical sensors and so on for not too high data rate sensors.
Okay, and those I can use on any Nordic SoC?
Those work on any Nordic SoC. In fact, it will work on any Nordic product that contains the ARM Cortex CPU, which is basically anything except for our premix. Then for more advanced use cases, we have the Axon NPU, which is built into the NRF54 LM20B SoC. This is a in-house developed neural network accelerator and NPU, neural processing unit, for accelerating standard TensorFlow Lite models that have been recompiled to work with the Axon NPU architecture. With the Axon, you can achieve up to 15 times higher energy efficiency and 15 times faster inference than running the same TensorFlow Lite model on ARM Cortex-M33 clocked at the same speed.
So you would have this TensorFlow Lite model, and then the same model could also run on the Axon's NPU. Do you need to do anything else there, or can you just run it?
No, so we have a compiler tool that takes in the TensorFlow Lite model format and then converts it into the Axon compatible C header files that the Axon NPU works with.
Okay.
So the Axon NPU is completely developed in-house, and we also, of course, develop all the tooling for it because of that. And we also have options for developing models for Axon in the Nordic Edge AI Lab, like, for example, a custom model builder, which allows you to upload your data and specify the network architecture, just like you would in a Python-based TensorFlow workflow, but in our web tool, which makes it a little bit easier to set up if you're not familiar with all the in-depth development tools with Python and such.
Okay, so what's the use case? Like, in what case would you want to say, okay, I would rather use Axon instead of Neuton models?
So for Axon, it's intended for more experienced AI developers, and it's intended for a little bit more advanced use cases. So where the Neuton models are great for low data rate time series sensors, Axon is better for data rates, higher data rate sensors. It's more intended for things like audio recognition, keyword spotting, wake words, all up to a low resolution black and white image recognition. Yeah. So in addition to the model builder for Axon, we also have this automated pipeline for creating wake word models, which is called text to wake word. It's where you can put in a wake word as text, it's plain text in a text box, and then our tool will automatically generate an Edge AI model that recognizes a keyword or a wake word in this case from spoken language.
Okay, which spoken languages does it work with?
As of now, it works with American English and British English.
Okay.
In the future, we will also expand this to work with a keyword spotting model, which is a more liberal version of a voice detection model that can handle multiple classes of recognizing different words and not just one, like a wake word model.
Okay, nice. Anything else you want to leave us with?
If you want to learn more about this, you can go to nordicsemi.com/edgeai.